So this is the LCMS, and there is the solvents that feed into the LC system. You see that tubing comes down past the autosampler, and that tubing runs down to the pumps, runs down to the pump there. And then, so the pump pulls the solvent out of those containers, and it runs through a degasser to get the bubbles out, and then pushes it up into the valve, the injection valve. Okay, that injection valve connects to the autosampler, where you put your samples, and the needle comes over to your sample. The syringe pulls some sample and then puts it in the valve. That gets injected on the column, and then after the column, we have it connected to the detector, the mass spectrometer here. But we are going to bypass the LC system. We are not going to be doing chromatography. We're going to push our sample in solution form directly into the mass spectrometer. This is called direct infusion. So we don't get any chromatography. We just see whatever's in our sample. So really, we just unscrew the LC, the outlet from the column, from the mass spectrometer, and then we are going to screw in this line. And at the end of this line, there is a little sleeve that fits over a syringe. And on the front of the mass spectrometer, for our convenience, there is a syringe pump. Okay, so we can see here, we're going to use this syringe, and to start, you're going to want to just fill it with methanol or some solvent to flush the system. Okay, now wear safety glasses when you are doing this process. Solutions can squirt around, and we don't want things getting in people's eyes, so wear safety glasses during this process. It's a good idea when you first get started. It can be a good idea to flush out the syringe. We're all going to be using the same syringe and the same tubing, and we are going to see cross-contamination. And usually you can account for that, but it's a good idea to flush things out. You also notice that Jackie is keeping a waste container up there. That's a good idea too. So she's going to snap the syringe in down here on the syringe pump mounted at the front of the mass spectrometer. And that base, that glass base, is snug up against the metal part right there. That's important. If it's pulled back a little bit, it's not going to pump properly. Okay, it's really important. You'll strip out the motor if you don't disengage the gear when you're manually moving this back and forth. You have to squeeze. Watch how Jackie squeezed. If you missed that, watch it again. So she squeezed to disengage the motor, then she pushed the base right up against the syringe, and then she let go and re-engaged the motor. Okay, she's going to put the sleeve over the needle, push it all the way. I encourage you to practice this a few times to see what it feels like, because it's very common for students to not push this all the way, and you'll see drips. You'll feel it kind of hit at the end. It's pretty tight. Okay, it's very common for students to not push it all the way, and you'll see drips dropping out of the syringe, and that means your sample's not actually making it into the line or into the mass spectrometer. So Jackie has the syringe loaded. She has the base. She's going to push pump on right there. And when you push pump on, it pumps at a speed that you set in the software. I'll show you that in a minute. Now, when you're first getting started, it's a good idea to push the pump on button and hold it. And you see it flashing right there. You'll hear it. It goes a little faster and flushes things out. Now, an important point is you saw earlier, Jackie squeezed in on those blue things on the base there and moved the base back and forth manually. Do not do that when the pump is actually on and engaged. Do not do that when the pump is actually unengaged. Okay, so then let's take a look at the software. All right, so when you're on the computer, you're going to want to open up LTQ Tune, not Excalibur. And this is how you manually run the mass spectrometer. The pause and start is counterintuitive. When you see pause, that means it's currently paused. And if you click pause, that means it's actually scanning. You see now it's scanning, and it has that kind of weird play button going there, but it's actually scanning right now. Now, the first thing you want to do is make sure you have the correct tune file loaded. It is loaded here. It shows you up at the top, but it's called CHE433 Fall 2021. So you need to make sure you have the correct tune file loaded. You can also check the pump speed. That's if you click on the little syringe pump icon. You saw me do that there. I suggest you have it set at 20. You have to either hit apply or OK in the software for things to actually be applied. Note the signal levels there that I just kind of highlighted, and you can see this is the mass spectrum in real time. as that syringe pump sprays into the mass spectrometer. So I'm going to hit the play button, which you would think means, oh, you should start, you should play, but that actually means pause. So I've paused the mass spectrometer. So I was just running the methanol blank there, and that's a good idea to do. Sometimes you're going to have to, if the person before you didn't flush the instrument well enough, you're going to have to flush the instrument. But you need to see what ions are in there and what the signal level's at before you start your stuff. If you don't have a background here, you're really not going to, if you just jump straight to your sample, you're really not going to have an idea of what peaks are new and what the signal levels are at. So run a methanol background, see what's already in the system, what peaks are already there when there's supposed to be nothing in there before you actually run your sample. Okay, so I've replaced the methanol. I pulled up in the syringe some MDMA, which has a molecular weight, a nominal molecular weight of 193. And I went ahead and primed with the syringe, and now I'm just flowing the syringe. Notice that it hasn't changed much from the background. It takes time for things to flush out. Allow time for things to flush out. That's, students often get frustrated and say, I didn't get anything, or they'll look at a peak from the background and be like, oh, mine was 413. Just wait. Just allow time. There we go. Did you guys see that peak at 194 shoot up? So now the system has flushed out, and now my MDMA is showing up. I'm in positive mode, and that is the peak that I expect. That is the nominal mass. Notice the background ions are still in there, but the peak signal for me is much, much higher. So I've got a good looking spectrum now, 194 for MDMA, and I want to record it. So I click on that camera icon. I specify where I want to record, and then I give it a file name. All right, and you want to record your data. You want to capture your data in your folder, within the 433L folder. And then I hit start. And once I hit start, it's recording until I hit stop. And I can say OK and make that window go away. Now I'm actually going to, so I'm getting a 194 spectrum here. I'm going to play with the acquisition parameters. Right now I'm scanning from 100 to 500. I'm going to go ahead and do an MS-MS spectrum. So I want to isolate 194. Nothing's happening because I didn't apply. And I'm going to say in a collision energy of 30. That's a pretty good collision energy. And there we go. There we go. I just had that MS-MS peak pop up. I don't need to go all the way from 100 to 500 when I'm doing this scan. So I went ahead and said, let's just go from, since the parent is at 195, I said, let's just go from 50 to 200. I don't see any of the parent left. My fragmentation energy is high enough. I'm going to go ahead and, so I don't confuse myself, I just adjusted the display to not show me any decimals. All right, and we see that fragment there. That fragment should be fairly unique for MDMA. But I can also play with the collision energy. See, when I drop the collision energy low, I get that 194. I get the parent. And then when I put it at a moderate collision energy of, say, 15, I start to get a little bit of fragment. Do you guys see that fragment? I think it's at 163. Increase the collision energy a little bit more. There's a little bit of the parent left at 194, but mostly fragment. And then when I increase it up to, say, 25, then I have primarily fragment. So I captured the MS spectrum of MDMA, and then I isolated the parent at 194 to give the MS-MS spectrum of MDMA. So between those two things, I should be able to definitively say that was, in fact, MDMA that I was putting in. So let's look at the data I just recorded. You can look at it in Qual Browser or in the newer version. This one has Qual Browser. So I was recording that signal for this certain period of time. You can see down below. This is not really a chromatogram, but if I click down below, you see there's my data for the MS1 of MDMA at 194. And then you can see at about, 0.4 minutes there, I switched to the MS2 spectrum, and I can click around, and so I can get that MS2 spectrum. And the code for everything is right down here. You can see that this says I'm in positive mode with ITMS ion trap. That tells you, oh, I isolated 194 and did MS2 and scanned from this distance. So that little code down at the bottom can tell you what you're looking at. This says ITMS is an ion trap, positive mode, and then it was just a full MS scan. So the signal versus time doesn't matter a whole lot. You're just going to show the mass spectrum and the MS-MS spectrum for the compound that you acquired. Okay, so after I've acquired my data, I'm going to put the methanol, after I'm done, or probably in between samples, I'm going to put a methanol blank back in and try and flush the system. This is the syringe full of methanol after I ran MDMA. And you guys can see it's still screaming hot with MDMA. That's at 10 micrograms per milliliter. We could probably honestly go down to 1 microgram per milliliter. So there's kind of constant cross-contamination here, and you spend a lot of time flushing the instrument. And just to illustrate that, so I'm just flushing methanol through right now. To illustrate that, I'm going to show you. You guys don't need to do this, but I'm going to split the screen so that we can in real time watch the signal versus time for the MDMA peak here at 194. And I'm just letting the syringe flow. And if you watch this over time, I'm probably going to speed this up. You'll see the signal drops a little bit, but it does take time to flush out most of the MDMA. You want to be courteous and definitely flush the instrument after your turn. Allow time to flush the instrument. It's quite rude. It's bad lab etiquette to just leave the instrument screaming hot with your sample. So flush the instrument after you're done. And you can see that the signal's decreasing a little bit for this 194, but there's still a fair amount of it, and that's kind of in the background. You want to flush as much of it as possible. Now, one thing I encourage you to do is flush a syringe full of methanol, and you can push that through as fast as you can. So to change the flow rate, you're going to go and click on that little pump icon, and you can adjust the flow rate up to 50. That's 50 microliters a minute. I generally wouldn't go, when I'm actually, this is just me flushing, I generally wouldn't go above 20 microliters per minute when I'm actually trying to run a sample. So when everything's done, you've flushed everything, you're going to want to turn the pump off, and you always turn the pump off before you disengage the little base there, the motor to the base. So you're going to disengage, move that guy back so that you can get the syringe out, and you're going to put your stuff to take the syringe out. And you're going to put your stuff in a waste up top. I like to bring a waste beaker, put my stuff in the waste. There is a waste below the instrument. And there's a little, it's got a white cap on it with a hole in it. You can just pour your waste in there when you're done. But I generally keep my own waste beaker. Don't just use one that's already up there. Only use your own beaker there, okay?